Hey everyone, welcome to today's Explainer. So, we're diving into something super fascinating today, an investigation into the intelligent green Internet of Things. Look, we all absolutely love our smart devices, right? But have you ever actually stopped to think about the massive environmental toll of all this digital connectivity? As our physical and digital worlds completely merge, the global stakes for our planet are skyrocketing. We're going to unpack exactly what that means today, and more importantly, how we can actually fix it.
To really wrap your head around the scale of this, just think about this projection. By the year 2030, we are projected to have an absolutely mind-blowing 100 billion connected devices globally. Yep, that is billion with a B. From our smartphones and smartwatches to agricultural drones and autonomous vehicles, our world is rapidly becoming this massive, intricate web of interconnected technology.
But, there's a very immediate physical cost to all that incredible convenience. In 2022 alone, cellular networks emitted a staggering 445 million tons of CO2. And with 5G spreading like wildfire, that number is on track to rise significantly. The sheer amount of energy required to keep our digital world spinning is creating a very real, very physical problem for our atmosphere.
Okay, let's dive into this. Here's our roadmap for today. We're going to explore the IoT energy crisis, introduce the Green IoT, take a peek under the hood at the 5 layers of IoT, see how it all works in the real world, and finally, look at how we actually fix this massive energy drain.
All right, let's kick things off with Section 1, the IoT energy crisis. To really get how we arrived at this critical juncture, we need to quickly frame the historical context and appreciate the sheer, unprecedented scale of the networks we've built.
The Internet of Things isn't exactly a new idea. It's wild to think about, but back in 1982, we had the very first connected drink vending machine. Then by 1990, someone somehow decided we desperately needed an internet-connected toaster. Fast forward to 1999, IBM invents the MQTT protocol, basically a foundational standard for machines messaging each other. And then, boom, 2010, Google launches its self-driving car concept. We literally went from a novelty vending machine to autonomous vehicles navigating our streets in just a few decades.
And that rapid evolution brings us to a frankly mind-boggling reality. Scientists anticipate that by 2030, global digital content will be 10,000 times greater than it was in 2010. Let that sink in, 10,000 times. All of this data needs massive storage space, intense cloud computing power, and enormous bandwidth. And well, all of that needs electricity, which directly drives up carbon emissions into our atmosphere.
Which brings us right to Section 2. Enter the Green IoT. Because to fix this impending disaster, we can't just unplug everything, right? We need to fundamentally rethink how we build, deploy, and manage these vast networks of devices.
So what exactly is it? Well, researcher San Murugesan defines green technology as the study and practice of developing, utilizing, producing, dismantling, and disposing of computing devices with minimum environmental impact. The absolute key takeaway here? True green IoT is not just about saving a bit of battery life when your device is turned on. No, it's about the entire life cycle of the device, from the factory floor all the way to the recycling bin.
Let's break down the 4 pillars of Green IoT that actually make this possible. First up, we've got green uses. This is all about employing devices while actively limiting their power consumption. Second is green utilization, focusing on recycling and repurposing old electronic equipment so it doesn't just sit in a landfill forever. Third, green planning. This means designing and constructing components and cooling equipment to be inherently energy efficient from the get-go. And finally, green manufacturing, making sure the actual physical production of these electronics is eco-friendly. So it's a completely comprehensive end-to-end approach.
Moving right along to Section 3, the 5 layers of IoT, we're going to look under the hood, so to speak, to see how these invisible systems are structurally built and where all that power is really going.
This brilliantly illustrates that foundational architecture of the Internet of Things. It's this complex, hybrid system of hardware, software, and communication protocols. And to make these networks truly green, engineers literally have to optimize every single one of these layers, because each layer has its own unique power demands.
Walking through them step by step, we start down at Layer 1 perception. These are the physical sensors, the cameras, the RFID tags out in the real world collecting data. Then, that data gets moved by Layer 2 transport, using protocols you definitely know, like Wi-Fi or Bluetooth. Once it gets where it's going, Layer 3 processing takes over, using massive cloud databases to analyze everything. But routing all of this requires Layer 4, the network layer, which relies heavily on some seriously power-hungry hubs and switches. And finally, the data hits Layer 5, the application. That's the smart home interface or healthcare dashboard you actually interact with. Highlighting this structure is absolutely crucial because components like those perception sensors and network hubs consume massive amounts of electricity, making them prime targets for green optimization.
All right, let's see how all this builds into Section 4, IoT in the real world. Time to shift gears from the abstract architecture to how these 5 interconnected layers actually impact your daily life and modern industries.
Just look at the vast ecosystem of industries out there constantly pinging the computing cloud for data. We're talking agriculture, education, law enforcement, environmental safety, the whole shebang, all relying on continuous wireless communication. Every single connection here represents active data transmission, and because of that, persistent energy consumption. To connect this directly to you, just think about the stuff you use every day. In smart homes, we rely on energy meters, smart HVAC systems, and digital locks. Out in agriculture, farmers are literally using drones for crop assessment and precision farming. In transport, we're seeing autonomous vehicles and smart traffic management to clear up congestion. And in healthcare, wearable monitors are tracking cardiac health in real time. All these incredible advancements completely rely on those power-hungry layers we were just talking about.
Which brings us to our 5th and final section, fixing the energy drain. We know the scale of the problem now and the architecture involved, so let's get into the micro-level technical solutions. Exactly where is the power being wasted, and how on earth do we stop it? Interestingly enough, technical energy drains often kind of mirror human behavior. A major issue is what's called idle listening. This is when a device stays on high alert, just burning through power, waiting for a message that simply isn't coming. It's exactly like staring at your phone, waiting for a text instead of just putting it in your pocket. There's also overhearing, where nodes waste energy processing background chatter that isn't even meant for them, and collisions, where data basically crashes into itself and has to be resent. To fix all this, Green IoT transitions devices into a green node state, using some really clever tactics to cut out the waste.
So here are the actionable preservation approaches engineers are deploying right now. First up is node activity management, basically using sleep scheduling so devices only wake up when they strictly have to. Next is data aggregation. This is combining multiple data packets into one single transmission to cut down costs. Then we have MAC protocol optimization, which tweaks the duty cycles, essentially a device's rhythm of listening and sleeping, so it isn't constantly draining the battery. They're also rolling out lightweight security management, ensuring encryption runs super efficiently, and energy-efficient routing, which is all about finding the path of least resistance for data to travel. Combining all these tactics drastically, and I mean drastically, cuts down the energy footprint. So, as we rapidly hurtle toward a world with 100 billion connected devices, we really have to ask ourselves a crucial question. Take a quick look around your living room right now. What is the true environmental footprint of your own smart home? The technology to build a greener digital world absolutely exists, but it requires awareness and action at every single level, from the manufacturers designing the microchips, all the way down to all of us using the devices. I really hope this explainer sparked some curiosity and gave you a fresh lens to view your connected life through. Until next time, keep questioning, keep learning, and thanks so much for hanging out with me today.